On August 5th, 2026, NASA published a finding that directly overturned something scientists had assumed about Pluto for years, that this small frozen world, sitting more than 3 billion miles from the Sun, was simply too cold, too distant, and too geologically inactive for anything liquid to still be moving beneath its surface today. Alan Stern, the principal investigator of the New Horizons, mission and lead author of this new study, put the discovery in exactly the terms it deserves, stating simply that Pluto never stops surprising us. Buried within imagery gathered more than a decade ago during New Horizons' historic 2015 flyby, researchers have now found the first direct evidence of liquid actually flowing on Pluto's surface, not billions of years in its ancient past, but recently, likely still happening today, welling up from underneath one of the largest glaciers anywhere in the solar system. This is the real story of what NASA actually found beneath Pluto's frozen crust, and why it adds genuine, fresh weight to one of the most surprising ideas in modern planetary science, that this small, distant world may be hiding an entire ocean of liquid water beneath its ice. To understand why this new finding matters so much, you first need to understand exactly what Sputnik Planitia is, and why it has already served as the central piece of evidence in the broader case for a Pluto ocean for years. Sputnik Planitia is the western lobe of Pluto's famous, instantly recognizable heart-shaped feature, an enormous, roughly 750-mile wide basin filled with nitrogen and methane ice, formed billions of years ago when a massive object slammed into Pluto's surface, carving out a deep depression that has been slowly filling and reshaping itself ever since. From the very earliest analysis of New Horizons' 2015 data, planetary scientists identified this specific basin as their strongest single piece of evidence for something hiding beneath Pluto's crust, because of a genuinely elegant piece of physical reasoning involving the basin's own position on the planet. Sputnik Planitia sits almost exactly opposite Charon, Pluto's enormous companion moon, on the dwarf planet's own surface, a specific alignment that should be essentially impossible to maintain purely by chance over billions of years, given how gravity and tidal forces work between two closely orbiting bodies. Researchers determined that if Sputnik Planitia represented a region of unusually concentrated mass, exactly what you would expect if a dense, liquid water ocean sat beneath a comparatively thin section of the overlying ice shell in that exact location, Pluto's own rotation would naturally have reoriented itself over time, gradually shifting until that extra mass settled into direct alignment with Charon's own gravitational pull, precisely the configuration New Horizons actually observed. This process, called true polar wander, provided a genuinely compelling, physically grounded argument that something denser than ordinary ice, almost certainly liquid water, had to be sitting beneath this specific part of Pluto's surface. Follow-up research throughout the years since has continued refining exactly what that hidden ocean might actually look like. A study published in May of 2024, led by researchers analyzing the specific pattern of cracks and bulges visible across Sputnik Planitia's surface, modeled the ocean's likely thickness and composition in considerable detail, concluding that Pluto's subsurface ocean most likely measures somewhere between 25 and 50 miles thick, sitting beneath an overlying ice shell of comparable depth, and that the water itself is probably around 8% denser than ordinary seawater here on Earth, roughly comparable to the famously salty water of Utah's Great Salt Lake, dense and salty enough that a hypothetical swimmer would float in it with remarkable ease. A separate, earlier study, published in the journal Nature Geoscience, had already tackled one of the most persistent puzzles surrounding this entire scenario: how a body this small and this far from the Sun could possibly keep any ocean from freezing solid over the full 4.5 billion year history of the solar system. That research proposed that a specific layer of gas hydrates, ice-like compounds trapping gas molecules within their crystal structure, could function as an unusually effective insulating blanket, sitting between Pluto's rocky core and its overlying ice shell, slowing the escape of the planet's own internal heat dramatically, and helping preserve a genuine long-lived liquid ocean far longer than a simple, uninsulated model would otherwise predict. This brings us to what NASA actually announced this past August, a finding that moves the entire conversation from ancient history and long-term preservation into something considerably more immediate and dynamic. Researchers, again led by Alan Stern, returned to New Horizons' original 2015 imagery, specifically to re-examine the northern edge of Sputnik Planitia, and identified a specific, distinctive pattern of darkened surface features stretching across that region, a pattern that, on close comparison, closely resembles the visual signature left behind on Earth's own glaciers, when they become wetted, either by rainfall or by liquid emerging from underneath the ice itself. Here is the detail that makes this finding genuinely significant, rather than simply another ambiguous surface marking. Pluto's atmosphere and surface temperature make liquid nitrogen rain a physical impossibility under any currently understood set of conditions. There is no plausible way for these specific darkened patterns to have been produced by anything falling from Pluto's sky. That leaves only one remaining explanation consistent with the physical evidence, that liquid nitrogen is actively rising up to the surface from underneath the glacier itself through a process called basal melting, seeping upward through cracks in the ice from some warmer layer sitting below. This represents, in NASA's own words, the first evidence of recently flowing liquid anywhere on Pluto's surface, a genuinely new category of discovery distinct from the broader, longer-standing case for a deep, ancient subsurface ocean. Researchers involved in the study have been direct about what this specific finding actually suggests, that Pluto is not simply a static, frozen relic that achieved its current geological configuration billions of years ago, and has remained essentially unchanged ever since. It appears to host what scientists are describing as a new kind of time variable feature, surface conditions that are still actively changing, driven by processes occurring beneath the ice in something closer to real time, rather than processes that concluded in Pluto's distant ancient past. It is worth being precise about the specific relationship between this newly discovered surface seepage and the deeper, larger-scale subsurface ocean researchers have been studying for years, since these represent two related but genuinely distinct phenomena. The broader ocean hypothesis, built primarily from Sputnik Planitia alignment with Charon and its own internal density profile, describes a genuine large-scale layer of liquid water sitting deep beneath Pluto's crust, insulated by an overlying ice shell tens of miles thick. The newly discovered basal melting signature involves liquid nitrogen specifically, a different substance entirely, apparently welling up through a comparatively shallow, localized process occurring much closer to the surface, within or just beneath the glacier itself, rather than directly tapping into that same deep, planet-spanning water ocean. Researchers have proposed that this basal melting most likely draws on a separate, comparatively localized heat source, potentially involving the same radioactive decay processes believed to help sustain the deeper water ocean, or possibly reflecting subtler, more localized geological activity specific to this particular region of the glacier. Even accounting for this distinction, the discovery still carries genuine significance for the broader picture of Pluto as a whole, because it provides fresh, independent evidence that this small, distant world remains considerably more geologically active than the prevailing view of Pluto held for decades before New Horizons ever arrived there. Before the 2015 flyby, most planetary scientists expected Pluto to be a geologically dead world, a simple, ancient, cratered ball of ice that had settled into permanent stillness billions of years ago, with no meaningful ongoing internal activity of any kind. New Horizons overturned that expectation almost immediately, revealing towering mountains of water ice, evidence of past cryovolcanic activity, and the young, remarkably crater-free surface of Sputnik Planitia itself, all pointing toward a world with a considerably more active, more complex geological history than anyone anticipated. This newest finding extends that same revised picture directly into the present day, suggesting that whatever processes have kept Pluto geologically active across its history have not simply stopped, but continue operating right, now actively reshaping small portions of its surface in ways NASA's own scientists are only now beginning to properly document. It is worth being honest about exactly how much uncertainty still surrounds this broader picture, since that honesty is precisely what separates genuine scientific progress from an overstated, prematurely settled conclusion. Alan Stern himself has been candid in discussing the broader ocean hypothesis, specifically that the evidence supporting it remains indirect, comparing the situation directly to a court of law, noting plainly that you usually cannot convict based purely on circumstantial evidence, however compelling that evidence might genuinely be. No spacecraft has ever directly sampled Pluto's interior, and no instrument has ever definitively confirmed liquid water actually exists beneath its surface in the direct, unambiguous way scientists would ultimately need to fully close this case. What researchers currently have is a steadily accumulating, increasingly difficult to dismiss body of indirect evidence, gravitational alignment, surface cracking patterns, and now, this newest addition, direct-to-visual. Evidence of recent liquid activity on the surface itself, all pointing consistently in the same general direction, even without yet providing the kind of definitive, direct confirmation a dedicated future orbiter mission could eventually provide. This growing body of evidence carries genuine significance that extends well beyond Pluto itself, connecting directly to one of the biggest, most actively pursued questions in the entire field of planetary science, understanding exactly how common subsurface oceans actually are throughout the outer solar system, and what that might mean for the broader search for potentially habitable environments beyond Earth. Pluto now joins an increasingly crowded list of outer solar system bodies, suspected or confirmed to host liquid water beneath their icy surfaces, alongside Jupiter's moon, Europa, Saturn's moon, Enceladus, and several other icy worlds currently under active study. If a small, distant dwarf planet sitting far outside the traditional habitable zone and receiving only the faintest trickle of solar energy can nonetheless maintain a genuine, long-lived subsurface ocean, insulated effectively enough to survive across billions of years, that finding meaningfully expands the range of places throughout our own solar system, and by extension throughout the wider galaxy, where scientists might reasonably expect to find similar hidden oceans, and potentially the conditions necessary to support some form of life. Step back and consider what this entire discovery genuinely represents about the continuing scientific value of a single spacecraft flyby that concluded more than a decade ago. New Horizons flew past Pluto for only a matter of hours in July of 2015, gathering as much data as its instruments could possibly capture during that single brief encounter before continuing onward deeper into the Kuiper Belt. And yet, more than 11 years later, researchers are still returning to that same original data set, applying fresh analytical techniques and asking new, more sophisticated questions, and continuing to extract genuinely new, previously unrecognized discoveries from images that have already been examined and studied for over a decade. This latest finding, evidence of liquid nitrogen actively seeping up from beneath one of Pluto's glaciers, is a direct product of exactly that kind of patient, ongoing reanalysis, proof that a single, executed spacecraft mission can continue yielding genuine scientific discoveries for years, and quite possibly decades, after the spacecraft itself has already moved on. So here is the honest, complete picture behind what NASA has actually found beneath Pluto's frozen surface. Beneath the northern edge of Sputnik Planitia's massive glacier, liquid nitrogen appears to be actively rising up through cracks in the ice, likely happening right now, the first direct evidence of recently flowing liquid ever documented anywhere on this distant world. That finding sites alongside years of separate, steadily accumulating evidence, suggesting Pluto also hides something considerably larger and deeper, a genuine subsurface ocean of salty, liquid water, thick enough and dense enough to float in with ease, insulated beneath tens of miles of overlying ice by a specialized layer of gas hydrates that has apparently kept it from freezing solid across more than 4 billion years. Neither piece of evidence has yet been definitively, directly confirmed the way a dedicated future mission eventually could, but together they paint an increasingly difficult to dismiss picture of a small, distant, supposedly frozen world that remains, even today, considerably more alive than anyone reasonably expected before New Horizons ever arrived there. If you want to see what future research continues to reveal about exactly what is happening beneath Pluto's icy surface, subscribe and turn on notifications, because scientists are still actively mining data from a single flyby that happened more than a decade ago, and they have already said Pluto still has more secrets left to give up.